Hi guys. Okay, so let's look at this problem that relates to gravimetric analysis. So first of all, what is gravimetric analysis? In gravimetric analysis, we take a sample, which is, mixture of certain substances, and we want to determine the mass of the substance that is present in the mixture. And that mixture is like, let's say, a homogeneous mixture. So we don't even know how much of one component is in grams of that. So what are we going to do? We are going to take that sample, which is a mixture of that substance, a few substances, and then we're going to subject it to some kind of a chemical treatment. In this chemical treatment, the substance that is of interest to us is termed as the analyte, and it crashes out. In other words, it was soluble before. After the chemical treatment, it becomes insoluble. So when there is a change of physical state, that is what it means, that going from an aqueous phase to a solid phase. So once it's solid, what we can do, we can easily isolate it. So after the separation and drying and all these other different steps, we are able to extract that particular sample, which was a part of that mixture, and then we can weigh it, and then we can get the grams of it. So this is how we perform this, and there is more detail or more visualization. You can look so many of these places on the internet or even in the book, but let's look at how we're going to solve this problem that relates to finding the mass of the analyte in a sample. So in this case, there is a sample. The weight of that sample is the sample's weight is 1.1324 grams. Okay. And in that, we want to find out the percentage of the chloride ions. So we take that sample, we subject it to chemical treatment, and we get silver chloride. So we are not getting the chloride ions, but we're getting silver chloride. And the silver chloride we are going to use as our medium through which we will determine how many chloride ions are present. So it's a simple stoichiometric conversions. So here overall it's a parts to whole problem. So our reaction is silver ions reacting with the chloride ions in the aqueous medium gives silver chloride, which is a solid, and the weight of this silver chloride is let's write this down, is the weight is 1.0881 grams of AgCl. Okay. Now, the first step is convert the grams of AgCl to the moles of AgCl. Next step is mole to mole ratio. And the third step is convert those moles to grams. So it's really that simple. Okay, so let's do this first. Grams of AgCl, and then obviously when we do grams to mole conversions, we need the molar mass. So I already calculated that. So we have here 1 mole of AgCl weighs 143 grams, 143 grams of AgCl. It's very important when you show the working, you should show all the details. Okay, next is the mole to mole ratio, because our main analyte is the chloride ions. And so we want to cancel out the AgCl. So here you see that it's 1-to-1 ratio between AgCl and the chloride ion. So next is, since we want the grams, so we see 1 mole of chloride ions is 35 grams of just the Cl. And yes, it has a charge. So it's very, it's a very small amount of change with that in the chloride ions. So you're going to now see that you have AgCl and the grams of AgCl cancel out, moles of AgCl cancel out, moles of chloride ions and the moles of chloride ions cancel out. So what do you get here? You get 1.088 grams, sorry, not grams, it's canceled out, 1.0881 times 1 times, this was 1-to-1 ratio, right? So this is 1 and 1 So that's important. Okay. And then comes the 1 times 35 divided by 143 times 1 times 1. And what do you get here? Okay, so now after this calculation, we get 0.266 grams of chloride ions. Now you're going to take this is a part, right? 0.266 grams over the total weight of the sample, which was 1.1324 times 100. So let's do this. So here we have the parts of the analyte, okay, over the whole of the sample. So times 100%. So in other words, analyte, the weight of analyte in grams over the weight of the sample in grams times 100%. So let's do this. So we have 0.263 divided by, and that's the grams, divided by 1.1324 grams times 100%. So let's see, what do you get here? Okay, so after this calculation, you get 23.51%. Okay, and that the book is saying 23.76, so it's close. Okay, so this is how the amount of chloride ions present in the sample, or chlorine ion or chloride ions present in the sample, and that is 23.51%. Okay, so that finishes this part here. And if you have any questions, you can ask. And at the same time, it is important that you start practicing. All right. Thank you and take care. Bye.